I'm Dave Kassler, amateur radio call sign KE0OG, here with another edition of Ask Dave. In AD 68, I put together the Ultimate 3 QRSS/Whisper transmitter from QRP-Labs. This came to me via viewer Michael Lloyd, who has sent me some other things too, and I'm starting to get really badly behind on them. Anyway, I was quite fascinated by the ability for very little money to build a dedicated Whisper transmitter. And I put it together and put it on 30 meters. Now, unbeknownst to me, because their website is kind of confusing, I put a bandpass filter instead of a low-pass filter into it, and the fellow in charge of QRP-Labs wrote to me, sent me a comment as a result of that video saying, hey, you did it wrong. And he said he was going to send me the 30-meter low-pass filter. And I went looking at the website that they had and discovered that they have a receiver kit. And so I got interested, and we exchanged some emails, and lo and behold, not only came the promised 30-meter low-pass filter, but also came the 20-meter kit, which has a 20-meter low-pass filter and a 20-meter bandpass filter. Turns out the bandpass filters go into the receiver. So what I've done so far today is that I built the 20-meter low-pass filter and then reprogrammed the little Whisper transmitter to be on 20 meters. So you can look for me in 20 meters. I'm going to leave it up for quite a while, I think. And I'm going to start building the receiver kit. Now, the receiver kit, it has it provides an output to a PC or something like that, and my long-term plan is to see if I can get a Raspberry Pi to do that. Anyway, what I thought I'd show in this video is just the process of putting together that little tiny 20-meter low-pass filter, and then integrating it in with the transmitter. And then I had to change the programming in it with the front buttons on the thing. This thing's got some buttons on the front. One says menu, one says edit. And just kind of as a little exercise in kit building and following the instructions and so on. I'm quite excited about this. I can, one of the things I'm going to use it for is my own personal propagation studies, because if you leave the thing on for 24 hours, I've hit before with the 30-meter, I've hit New Zealand and Australia, and I think I got one in South Africa. What I'm going to do over a period of several days is look at these and see, okay, what time of day does it work, and see if I can't correlate that with doing some DX. Okay, we're going to modify this thing right here. This is something I did a previous video about. The Ultimate 3 QRSS, that means really slow Morse or Whisper, weak signal propagation reporter from QRP-Labs. I've got it set up to transmit on Whisper, and I've received reports from the little quarter-watt transmitter in here, and the nice little loop antenna that I have here have gotten all the way to Australia. So what I'm going to do is take this thing apart and show what I need to fix inside. Okay, with screws off, let me take the top off right here and take a look inside at what all we've got. This right here is the display board, which has the display on it. Built on the back of this is the transmitter board itself. This particular little doodad sets the contrast for the display. And so this is the transmitter board. Now the two things plugging into it. First, this is, I'll call it the VFO board. How's that? It is keeps the frequency. It's got a little tiny chip on here which you can really not see very well. that actually sets the frequency. It puts out a square wave. And then over here is supposed to be the low-pass filter here, which will filter out all the harmonics from the square wave, which will then put out a sine wave. This thing that I've got pasted in here with double-sided tape is a 12-volt to 5-volt DC to DC converter. And so I've got 12 volts in. I went ahead and put in a SO239 because I don't have much experience with BNCs, which is what they sent with it. The GPS/prog is a GPS receiver, and I have that receiver, and it's right here. I keep it up on the bookshelf. That's the actual antenna. This is the little receiver in here, and this right here just decodes stuff that comes out of here and puts it onto this cable right here. So what comes out of here is a 1 pulse per second, and when this thing says second, it means the same second as in the clock in the National Naval Observatory in Washington, D.C., which is extremely closely coordinated with Universal Coordinated Time. And then this next one right here indicates that a word, meaning a packet, is being sent down the wire to the little VFO. And what the VFO has on it is that it's got a quasi-crystal control. It is crystal controlled, not quasi. There you can just see the little chip. There's a little chip right in there that's the heart of it. That is a SI 5351 chip, which is a programmable oscillator. It'll put out any frequency you want. Here's a 25 megahertz crystal that keeps things in charge, and so it's direct digital synthesis of the frequency that it wants. It puts the frequency together as a square wave. Now, the from the GPS comes in this wire over here and then up into here, which quote disciplines this to the GPS. So if this starts to get a little bit off, it goes through a calibration routine, and then at the end of 4 minutes, I think it's 4 minutes, it adjusts, it puts in a little error to bring this clock up to speed so that the frequency it's putting out is actually what it's programmed to put out. You program via the menu and edit bars over there. Now this right here is supposed to be a low pass filter. Now what the low pass filter does is this is set up to transmit on 30 meters. Okay, we've got 10 megahertz, and again this puts out a square wave. Well, the harmonics, the first harmonic of any interest is actually the third harmonic, which is up quite a way. So if you put a low-pass filter in here, all that we'll get through will be a very nice little sine wave. There's a final amplifier tucked way down inside on the board. There it is. It's right next, you can't see it, it's right there. This is supposed to be a low-pass filter, and by mistake I put in a bandpass filter for that. And I got some feedback from the guy who makes these things, makes these kits, saying, oh no, 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 you don't put that in there, you put low-pass filter. Well, I'm going to move this from 30 meters to 20 meters. So I'm going to put in here a 20 meter low pass filter. And I've got the kit for it right here. 20 meter low pass filter. And put that in there. And then have to go in the front with the menu and the edit and everything like that and get it set up for 20 meters. Okay, that's step one. Step two, which is coming down the road, is to create this, which is a receiver kit. Now the receiver kit, in being rather different, it does want the bandpass filter. So there's the bandpass filter for that. And it puts out 2 audio signals in quadrature. If the laptop won't take a stereo input, then this converts all that to a mono. One of the problems with the QRP-Labs is that the kits really don't, in and of themselves, build anything. You have to put several of them together and do it in just the right way. I'm going to put together the 20-meter low-pass filter and get this transmitter back on the air. Here are the parts for the kit. A couple capacitors, a couple little headers, another little capacitor, and then 3 toroids that have to be wound. And it's got the wire for the winding, so I'll show you how the toroids are wound. The first step in winding the toroids is to pick the band. It's going to be 20 meters. Okay. So we're going to have 2 coils. I'm sorry, these are the capacitors. Then there's 1, 2, 3 coils. 1 and 3 here. 2 here. It's on a T37-6 yellow toroidal core, which is not very big, as you can see there. So we'll do L1 and L3 with 16 turns, L2 with 17 turns. First, we're going to unwrap the wire. And we want to do this carefully so that we don't kink the wire. That's not good. Okay. And then we're going to open it up like this and very carefully undo the wire. Yeah, the wire we've got is fairly long. Let's see how long it is. 3 feet. Okay, so that means we need 3 sections that are a foot long. Here we go. These don't have to be exact, but if you make one too long, you might end up with another one that is too short. Okay, we'll just put that there. We don't need the tape measure anymore because we can just fold this in half. Okay, a little hard to see the wire in the camera there. Okay, so we're just going to cut this. And we end up with 3 pieces of this little wire. Now this is magnet wire, and it's coated with the varnish so that it's actually insulated. So we take one of these things, and it says we're going to do 16 turns. Now, one time the wire passes through the body of the, I'll do it this way. If it passes through the hole once, that is a 1-turn coil by definition. Okay, we want 16, so now we have 1. So what we're going to do is just wind these around. Okay, kind of keeping it relatively tight, and it's a thread the needle operation. Okay, there are 2 turns. And we keep going. One thing I should note, in winding the coil, you try really, really hard not to overlap the turns. We're going to try and get them equally spread out. We can move them around a little bit later. The reason is it minimizes turn-to-turn capacitance if you have them the same distance apart, and for the same reason we're going to leave a little blank area down here so end-to-end capacitance will be less. Okay, here's what we come up with. A 16-turn coil. Okay, did it pretty quick. Here's what we end up with. A 16-turn coil. After we solder it in, we're going to spend a moment getting those windings a little more even, but they don't overlap. That's important. Okay, the coils are done. The next thing is to get them installed on this absolutely dinky circuit board. Look at that compared to the size of my thumbnail. It's about 2 thumbnails wide. That's it. Okay, let's get to work. Okay, we're going to use this little tool to put these in. It holds the circuit board here, and you can just flip it over to solder on the back, flip it back to put components in, move it around as you need to. This is just a really neat tool that I saw in someone's build video. It's very nice. It acts as a third and a fourth hand. Now what we see here is the toroid is in place, okay, through the right holes. Now what the manual suggests doing is just leaving the soldering iron on long enough that it will actually, the solder will boil away the varnish, and you don't have to worry about separately sanding it. I point out in passing that this is what the lead from the coil looks like when you pass it through. When you try to solder it right there, this whole thing acts as a heat sink. So what we're going to do is reach down under here and take most of that off, like that, so that it won't be so much of a heat sink, and we'll be able to better heat that particular solder point. Okay, let's see how we're doing. All these coils should be in series now that we've had them all added in. Okay, so if we use a very simple, inexpensive VOM, here we're going to test the continuity through all 3 coils. Let's see, through there. And look at that. Okay, we're getting through all 3 coils. Alright, now let's do the easy part, and that's the capacitors. Now, the instructions give us 2 tables, both of which give the same information for the winding of coils. 2 at 16 and 1 at 17. Okay. Now, as far as C1, C2, C3, and C4, it's a 180 picofarads, 390, 390, 180. Now, down here in the bottom, though, they've got the actual markings that are on them. 181, 391, 391, and 181. So that's what we're going to look for. Let's take these green ones, for example, and see if we can actually see the markings. That looks like 391, I think. That's 391, so we'll use that. You know, before we put on the end pieces, let's go through this and make sure these are a little bit more evenly spaced. Okay, the last thing we have to put on this little jewel are the headers, and they're going to go on each end just like this. Now, the manual suggests a trick to making sure these line up right, and that is that we put it in place, push the pins down in, and then solder it. To do that, we're going to have to take this apart just a little bit more. Okay, this right here is the 30-meter band pass filter, when what we wanted was the 30-meter low pass filter. So we'll just slip this one up and out of there, and notice it's got those pins like that. Okay, so what we're going to do is take the set of pins and we'll put them down in there just like that. Okay, and we got 4. Now we want the unit. We've got to get in and out. There's an in and out on this thing. Ground in, ground out. We want out down there and in over here. So we put it in place like that. So those pins are in exactly the right place. Now let's solder them. Okay, now we soldered it right there with those pins in place. So those pins just go in correctly. That's out, that's in. Okay, so what we're going to do is simply plug that in and leave it there. Okay, now this thing should be ready to transmit hardware-wise on 20 meters, but we have to reprogram the front. So let's get some power up and do that. Okay, well here it is. It's installed. So this little device right there is a 20 meter low pass filter, and the system is set up here. This is the time it will next transmit, 40 after the hour. This is the heartbeat from the GPS, and this is the UTC time, and it gives my location here. Okay, it's about to start transmitting in Whisper. When that hits 40 right there, it'll change completely what's on the screen. And into Whisper we go. It gives the mode. This is the channel it's operating on. You can have a whole bunch if you have a bunch of different filters that you can select between. The actual frequency 14097.1 is the actual transmitted frequency. If you were looking at this on a shortwave receiver, you'd be 1.5 kilohertz below that. 23 is the number of dBm that are being transmitted. In this case, about 0.2 of a watt. And this number is just sort of counting up as it goes through the protocol. And this number is supposed to be something that sets, if you want to set some external relays or something, you can do that. I don't use that feature right there. So when this thing gets tired of it, it then goes into a calibration phase, which decides, how much that it needs to change the clock internal to the machine here. This has a very accurate crystal clock that can do direct digital synthesis of any frequency wanted, and that's the frequency there. But even so, that's a tiny bit different from the GPS clock. So it's going to look at the GPS clock, compare it to the time it has, and then decide what kind of a tweak. It'll be just a few hertz one way or the other. Now see, we go into calibration here. It starts actually on the minute. And there we go. Now that takes about 4 minutes to get all the way through. So it very carefully calibrates itself, and it'll do that after every transmission. So the system is back in operation on 20 meters now. So let's look to see if it can be seen, if it's being heard by other Whisper stations. I'm going to leave this on more or less permanently. And I'm also going to build the new receiver module kit that's coming out. And so that will be the next step, both send and receive Whisper. One thing I forgot to mention, these kits are physically quite tiny. And this is the little box they came in. I thought it would be coming from somewhere in Europe, but no, it came from Japan. And that surprised me a little bit, but everything was right here. Was very convenient. Came rather quickly, I thought. Well, what's been accomplished here? I moved the Whisper transmitter from 30 meters to 20 meters. I've also got it up on the MFJ cobweb, so it's an outdoor antenna, so we'll see how well that does compared to what I had before. So I'm up to about 1/4 watt on 20 meter Whisper, and what I want to do with that is some propagation investigation, and we'll see what we can do. Thank you so much for the positive feedback I'm getting from everybody. I'm trying all different kinds of videos here. I'm going to be doing an interview video tomorrow that's going to be about coaxial cable, so I hope that hangs together. I was going to do a video about fixing an antenna that I have that that I use for my VHF and UHF, and I went to start doing the video and took SWR again, and everything was back to normal. So there wasn't much more troubleshooting, and that would have made for a pretty boring video. Please, if you would, click like and subscribe, because that brings these videos to the attention of others. YouTube uses that in their algorithm. Please also check out the tip jar and the Patreon page. I very, very much appreciate whatever you would like to do, because I can use it to do things like buy the little kits, put them together, and we can learn about these things together. My next big purchase, I'd like to be a real signal generator. One that actually is good on the ham bands and through a UHF or VHF. The problem with the inexpensive ones I've been building is their frequency really tops out way, 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 way below even the medium frequency band. So, thanks so much. Please be sure to use both feet when walking. This is Dave, KE0OG73.